Question number 16. The position coordinate of a moving particle x is alpha t cube, y is beta t cube. The speed of the particle at t is equal to 1 second is. So first I am going to take the velocity along x-axis by using dx over dt. So when I differentiate the given expression, we'll get 3 alpha t square. Similarly, if I go along y-axis, so dy over dt is there. When I differentiate beta t cube, so we'll get 3 beta t square. This is my equation number 1 and this is my equation number 2. So if I go for the resultant speed, we'll write vx square plus vy square. We all know this relation. Vx is 3 alpha t square, vy is 3 beta t square. So you could see we can take 3t square as a common. So inside the root we'll get alpha square plus beta square only. But according to the problem, the speed of the particle at t equal 1 second. So when I place the value of t, we'll get 3 times of alpha square plus beta square. So this is our final answer. So we can say my option number 4 is correct. So let's move on. Question number 17. The displacement of a particle y is a plus bt plus ct square plus dt4. The ratio of initial velocity to the initial acceleration. So first I am going to calculate the velocity by using differentiation dy over dt, and that will give you velocity expression. So when you will differentiate this d over dt, the value of y is a plus pt plus ct square plus dt4. When I will differentiate, we'll get 0 plus b plus 2ct plus 4dt cube. This is the velocity. But I need initial velocity. So for initial velocity, I am going to put time t is equal to 0 for initial velocity. So we'll get initial velocity is equal to v plus 2c into 0 plus 4d into 0. So we'll get only b. B is the initial velocity. Similarly, now I am going to calculate acceleration. So you know, if I differentiate the velocity expression with respect to the time, we'll get acceleration equation. So when I will differentiate this expression, we'll get 0 plus 2c only plus 12 dt square. But question says initial acceleration. So for initial acceleration, we can put time t is equal to 0. So a is equal to 2c plus 0 because t is equal to 0. So I have initial acceleration only 2c. So we have initial velocity and initial acceleration. But question want to calculate to ratio of initial velocity means v and initial acceleration a. The value of initial velocity v is b and the value of initial acceleration is 2c. So the final ratio is b upon 2c. So we can say my option number 4 is correct. So let's move on. Question number 18. In the question number 18, two particles of masses m1 m2 are dropped from tower of height h1 and h2. h1 and h2. Okay. h1 and h2. They reach the ground at time t1, t2 respectively. So this is the case of free fall. So we can use h is equal to ut plus half gt square. But initial velocity is 0. So we have a relation h is equal to half gt square. So on the basis of equation number 1, we can make a relation h1 upon h2 because half g will remain constant for both. So we'll have t1 square अपॉन T2 स्क्वायर, बिकॉज हाफ जी कैंसिल हो जाएंगे, और तो वी कैन राइट T1 upon T2 is equal to H1 upon H2 with the root. So T1 upon T2 is equal to H1 upon H2. So on behalf of that, we can say my option number 1 is correct. And you should keep in mind, in the case of motion under gravity, it is independent of mass. So we can say my option number 1 is correct. So let's move on. Question number 19. So now I am going to take the question number 19. A ball is thrown vertically upward, like that. Which of the following plots represent the speed time graph of the ball during its flight if the air resistance is not ignored? Air resistance is not ignored, so keep in mind. So if I, before going to the ऑप्शंस पे जाने से पहले अगर हम लोग इसके मोशन की सिचुएशन की बात करें, तो वन फोर्स mg इज एक्टिंग इन डाउनवर्ड डायरेक्शन एंड द डायरेक्शन ऑफ मोशन v इज अपवर्ड डायरेक्शन, बट एयर रेजिस्टेंस को हम इग्नोर नहीं कर सकते. तो व्हेन बॉल इज मूविंग अप, देन एयर रेजिस्टेंस इज एक्टिंग डाउन. So, and this air resistance is directly proportional to the velocity of the ball. But we can observe that the direction of mg and this force F is applied by the air resistance. Both are acting in same direction. And we know that if I go for the slope of speed time graph, then slope of this graph gives us tangential acceleration. So actually I am going to concentrate only the tangential acceleration. ग्राफ को स्लोप की हेल्प से सॉल्व करना इजी होता है, और मुझे पता है कि स्लोप ऑफ स्पीड टाइम ग्राफ गिव्स अस टेंजेंशियल एक्सेलरेशन. एंड इफ आई टेक ओनली एक्सेलरेशन इंस्टेड ऑफ फोर्स, देन विल सी, बिकॉज acceleration due to gravity is acting downward and plus kV. Why we are going to use kV? Because as I said, the acceleration is directly proportional to the velocity of the ball. कहने का मतलब ये है कि जितनी स्पीड से बॉल ऊपर जाएगी उतनी ही पावर से एयर का रेजिस्टेंस बॉल के मोशन को अपोज करेगा. तो ये एक्सेलरेशन ड्यू टू ग्रेविटी जी भी अपोज कर रहा है, और ये वेलोसिटी जो एयर के इम्पैक्ट से अपोज हो रही है वो दोनों सेम डायरेक्शन में होंगे. सो टेंजेंशियल एक्सेलरेशन को हम लोग माइनस साइन से लिखेंगे. सो इन दिस सिचुएशन वी कैन ऑब्जर्व द वेलोसिटी ऑफ द बॉल विल डिक्रीज एंड टेंजेंशियल एक्सेलरेशन will decrease. And you should keep in mind, this is the case of upward journey. When ball is going up, then acceleration is negative. And if I take the downward motion, then mg will act in downward direction, and the direction of motion is also in downward. दोनों एक साथ हैं. But in this situation, air resistance will act in upward direction. Air resistance का वर्क है बॉल के मोशन को अपोज करना. तो इस टाइम पर अगर मैं एक्सेलरेशन की बात करूं तो ये kv टाइम्स होगा अपवर्ड डायरेक्शन में. तो इस सिचुएशन में एक्सेलरेशन ड्यू टू ग्रेविटी एंड effect of acceleration due to air both are in opposite direction. So we'll write tangential acceleration for downward journey g minus kb. But in this time acceleration due to gravity is acting downward and kb is upward. So this is the equation for tangential acceleration. हम लोग देख सकते हैं कि अपवर्ड जर्नी में एक्सेलरेशन नेगेटिव है और डाउनवर्ड जर्नी में टेंजेंशियल एक्सेलरेशन पॉजिटिव है. और इस सिचुएशन में वेलोसिटी विल इंक्रीज बट टेंजेंशियल एक्सेलरेशन विल डिक्रीज. अब हमारे पास इन ऑब्जर्वेशंस के बेस पर हम लोग बोल सकते हैं कि माय ऑप्शन नंबर 4 इज करेक्ट. So let's move on question number 20. Now I am going to take 20. Which of the following speed time graph shows a realistic situation for a body in motion? So first I will concentrate a speed time graph. This is not a velocity time graph. This is a speed time graph. So speed can never be negative. So first option नहीं हो सकता. Fourth option is not possible because यहाँ पे negative भी आ रहा है. ये देखिए. First और four नहीं हो सकते. If I concentrate option number 3, so option number 3 will indicate at a single time t1 particle has two positions, and this is not possible. So there is no confusion. My option number 2 will be correct. So let's move on. Question number 21.